um, when we leave one and go to the other. There's a lot of overlap here. Okay. So in order to do this semester, we need to start off with some vocabulary and some notation. You're going to have to learn a lot of new terms and definitions and just know how to use them. I'm not going to make you regurgitate definitions, but you need to understand what's being said. And there's a lot of new notation, symbols. So we use a lot of Greek letters and a lot of English letters, if you will. And once we know the vocabulary, then we can start learning how to calculate different quantities and looking up and calculating different probabilities. And so there's a lot of math involved. There's a lot of mechanics involved before we can ever even think about doing inferential statistics. So once we have learned how to do all these calculations, then somewhere near the end of the course, we'll be able to put it together and start doing inference. Okay. So we're using the book Understanding Basic Statistics by Braze and Braze, the 7th edition. And we're going to cover in this semester chapters 1 through 4, and then we're going to skip over to chapters 7 through 9, and we're going to complete them, and then we're going to cover as much of chapter 10 and 11 as possible. So that's our outline for this semester. So let's jump right into some basic concepts. The first of which is, what kind of studies do we do in statistics? Well, there's two basic types: observational studies and experimental designs. So in this course and in most courses, we deal with observational studies. This is where we analyze data that has been collected without the researcher or anyone influencing or interfering with the results. Experimental design is very different. It's a more advanced topic, and what we do there is we design an experiment using subject matter expertise and statistical expertise, and we control the conditions under which things are created or produced, and we control the environment, and then when we're done, the results can help us either prove or disprove cause and effect. All right. Experimental design is the only area in statistics where we can actually prove cause and effect. Now let's talk about data and some terms that go with data. An individual is a term for any member of our population that we're wanting to study, or the population of interest. A variable is something that varies in value, as its name implies, and it's something that we're going to measure or observe on the individuals. It could be height, length, distance, pressure, weight, something along those lines. Population data is a term that refers to measurements or observations from the entire population of interest, and we call this a census. And the U.S. does a census every 10 years, or attempts to. And then we have sample data, and again, it's data that's collected just from our sample, which is just a portion of the entire population. Now, there are many types of sample or sampling techniques, and the book in section 1.2 does discuss these, and they're interesting, but we're not going to deal with them in this course, so I'm not going to cover them. But the types of samples that we are going to cover in this course include a random sample and a simple random sample. And some people have trouble determining which is which. So a random sample means that any individual in the population has exactly the same chance or probability of being selected. A simple random sample now does not talk about an individual, it talks about a group of individuals. Let's say size n. So we could let size n be, say, 30. Then a simple random sample of size 30 means that it's a sample of 30 individuals, and the chance of us selecting that particular group of 30 individuals in the population is exactly the same as any other group of 30. And we are talking about all the possible groups of 30, so there's a lot of overlap here. Okay? And we will use this when we get to inference in this course. Now, when we want to measure something about a population and determine something, we may be interested in, say, the mean lengths of fireflies. And so a mean is the same as an average. And if I'm interested in this population and I want to know what the mean of some value of the population is, that's a parameter. It's a true value that I don't know. In most cases, I won't know what this value is. So the concept of parameter goes with a population. Notice that parameter starts with a P over here, and notice that population starts with a P. And then statistics is a statistic is a measure on a sample. So it's that same characteristic or aspect of a sample. So it could be the mean or standard deviation of a sample. So, and again, statistics starts with an S, sample starts with an S. All right. So let's put this together in a brief example. So we want to study the average lengths of fireflies in Lynchburg, Virginia. To do this, we're going to use a little sampling theory. We're going to divide the city up into several thousand square grids of equal size. What we're trying to do is make it small enough to where if we send one person to that grid, they can easily handle or measure the fireflies on that one grid. So, and then just as a random number that I chose, let's say we randomly select 20 of those grids, and we send a researcher to each of those grids at dusk, and for 10 minutes, they're going to capture as many fireflies as they can, and then measure their length, and then release them without hurting them, okay? So we don't want any cruelty to fireflies, all right. So what is the population and what's the sample here? Well, the population are all the fireflies in Lynchburg, and there's no way we could measure all of them, and we wouldn't want to either. And then a sample, in this case, are the fireflies that were captured and measured by the researchers and released. All right. So what's a parameter? Based on this study, we said we wanted the average length of fireflies. That's what we're studying. So for this study, the parameter would be the average length of all fireflies in Lynchburg, not in Virginia, not anywhere else. We've defined our population as all the fireflies in Lynchburg, so the parameter is the average length of that population. And the statistic would be the average length of the fireflies that were measured. All right, well, I hope this helps put those first few basic concepts together and makes it a little more understanding. Now, as I've mentioned in the starting here video for this course, I'm requiring that you take lecture notes on each of the videos. And these are your lecture notes, but I'm requiring that you do that and then scan them in to the Google Drive that I've shared with you. And this counts as part of your participation grade. And I believe it's 20%. So it's a very large portion of your grade. So please make sure that you do that. And I've said extra points for neatness, but really this is for you. These notes are for you to go back and study. They're to help you when you do homework, help you study for tests, help you when you do your projects. All right. Well, I hope you've enjoyed